All right. Good morning, everyone. I'm John Veller at HMS Networks. I'd like to welcome you to our live webinar. If you're using the Teams app during this webinar, please use the Q&A button at the top of your screens for any questions. If you don't see the Q&A, you're more than likely to see the chat. You can put your questions in there. I'd like now to introduce you to our first presenter of the day, Jason Block. With over 20 years at HMS Networks and over 25 years of experience in industrial communications, Jason has assisted machine builders, system integrators, and factory owners throughout North America and South America in solving their most challenging data and connectivity problems. For our second presenter, we are thrilled to have Kurt Luke from Automation Intellect with us. Kurt brings over 30 years of expertise in the design and implementation of advanced manufacturing solutions, emphasizing IoT and analytics. His strategic leadership has been instrumental in developing the architecture of Automation Intellect's IoT platform, which delivers real-time operational insights and analytics. I'm going to pass it over to you now, Jason.
Thank you, John, for the introduction. Thank you, everybody, for joining us today. I want to give kind of a brief overview on HMS's value. We've been around doing networking for industrial networks for over 30 years. So our focus over time has really been a key enabling piece in allowing, information on factory floors to basically move from machines to machines, and then ultimately from machines to people. And we have a number of things that we do to basically be a key enabler in that. But when it comes to basically moving information from the factory floor and moving into the eyes of people who can make decisions off of that information, oftentimes it's critical for us to work with others to enable that. So our partners are a key element of our success. So today we'd like to profile one of those key partners with Automation Intellect. And with that in mind, I'd like to turn this over to Kurt Luke to get us started today. Welcome, Kurt. Kurt, you're muted.
All right. All sorts of technical difficulties today. Well, good morning, everybody. It is still good morning. My name's Kurt Luke, and I'm the co-founder and CTO of Automation Intellect, and we're coming live to you from, at least for me, from Charlotte, North Carolina. Thanks so much for joining today's webinar. So we've got a lot to cover. In the end, I'm hoping that you'll get a small taste of how you can leverage both the power of HMS as well as AI to literally implement an IoT solution in weeks, and more importantly, as the title talks about, getting a 50x return. And if you have any experience in the field of IoT, you should probably be a little bit skeptical of what I just stated, because getting 50x is hard. Frankly, implementing IoT is hard. It's really hard. And some of the factors of that is the fact that a lot of us have very outdated equipment and some modern equipment. You have a workforce that doesn't necessarily love change. You have worker shortages. You have high production goals, and they just keep getting higher. You put that all together, and you've got a pretty challenging situation when trying to implement projects like this. A lot of hype in the market, of course. So what I'm hoping over the next few minutes is to give us all an overview of what has worked for us in implementing these types of projects. So the agenda is a 5-step piece: developing a strategic IoT roadmap, analyzing the current infrastructure, which is where HMS comes into huge play, choosing the right IoT technology, pilot implementations, and finally with full-scale implementations. During the presentation, we put this together to try to mix the appropriate amount of theory with practical implementation experience. You need to know both, and I'm going to try to show and talk about a few gotchas along the way. All right, so let's dive in. So the first piece, this is a little bit theory, but it's not theory. It's only theory until you really start doing it. At AI, we've gone through this process with a lot of different clients, and that is helping them develop that strategic roadmap. And I want to highlight a few things that work and some that don't. So this first step, as I said, is developing the strategic IoT roadmap. The journey towards smart manufacturing isn't just about deploying a bunch of technology. It's really about creating a roadmap that aligns your business objectives and your operational needs together with that technology. And frankly, we can always tell in the sales process if a customer has performed this step, even just a little bit. Customers need to be able to answer basic questions like, what's your goal for this? How are you going to measure success? Or uh, have you even started some of these, trying to answer some of these questions? When we start digging into questions about the infrastructure is when we can tell really how serious the clients are. So let's talk about the foundation of any successful IoT implementation. And that first part is really understanding your business objectives. So typical, and these are generic objectives, but connecting the factory, improving OEE, reducing downtime, enhancing product quality. Your goals, and you, of course, you're going to add your own goals. The goals should be specific. We talk about this term called SMART. They need to be specific, measurable, achievable, relevant, and time bound. And let me just repeat, they have to be specific. We love it when a customer says, hey, we want to do a pilot on this particular line, and we want to see if you can improve it by 5%. That's something that we can really dig into. Just saying, hey, we want to see this technology. Well, that's great, but really we need to have something that we can really dig into. Okay, so let's talk about the main elements in the IoT roadmap. So most of those are up there. So we talk about business objectives. We discuss them, but really these are the drivers. You have to start with that. Right under that are the KPIs. You've got your objectives. What are the KPIs that are going to align with that? The next, where it really starts to get real, is the project plan. So you need to develop a comprehensive rollout plan, but you're going to start small and local, but you need to have a plan for the rollouts and be realistic with these goals, because it's going to take you longer than you want. That's just guaranteed. We usually are able to move faster than our clients just because there's just a lot of stuff going on. Change is hard. The next piece is the project team. Our best projects have dedicated individuals to them. Now, obviously, that depends on the size of your organization, and we know that everybody is short-staffed. That's just the reality. But our worst implementations have very little support and a lot of shared resources. So if you can have a dedicated team that's above, let's say you've got multiple plants across the world, it's better to have a dedicated team that can help to move each of these projects forward. And that next piece is network. We're going to talk more about this, but this is really the backbone of any project from an IoT perspective. If you don't have that well, you're basically building on sinking sand. The third element in here is around legacy systems. You all have them, and so you're going to have some questions around which ones stay and which ones are you going to have to replace. And retiring systems is harder than you think. So think through it. Which brings me to change management. Change management, the older that I get, the more I realize how important it is. Not everyone is going to be gung-ho about all this change, and you're going to need training and change management built into all of these implementations. The last piece that's not actually up on here is around financial management. No doubt this is going to cost you something. Hopefully, whatever you spend, you get more out, but it's going to cost you. There's going to be some upfront costs. So what's the budget? Is it realistic? All right. So these are some of the aspects of what is in your strategic IoT roadmap. I'm sure you're going to add more, but this is kind of a top level view of it. In the end, it's a comprehensive plan that aligns with our business objectives, addressing operational needs It's underpinned by realistic goals, timelines, and measurable success criteria. It's about ensuring that our journey towards smart manufacturing is as strategic, efficient, and as effective as possible. Okay, so step two. So we're diving a little bit deeper. The next critical step of developing the strategic IoT roadmap is really assessing your current infrastructure. And the infrastructure shouldn't be a surprise statement. It's pivotal. The infrastructure is the backbone for a profound transformation within our manufacturing operations. The evaluation is beyond just a simple inventory of our physical and digital assets. So think of it more like a health checkup for our manufacturing plant. And it's going to reveal, done right, it's going to reveal both the strategic and arenas requiring some intervention. So as the picture up here says, picture a professional. This professional is two people, two groups made of IT and OT with a digital tablet in hand. Okay? They're walking through the manufacturing floor. Their purpose extends beyond just looking. They're actively collecting data, scrutinizing performance metrics, envisioning the fusion of operations with cutting-edge IoT technology. So this scene captures sort of the essence of the initial step. It's a meticulous and deliberate examination of your present condition. The step really can't be overstated. You're literally plotting the next 10 to 20 years of your operations. And the main point of this assessment is probably the network infrastructure. You're about to put a huge load on probably an older infrastructure. And at this point, I know everybody doesn't love this, but IT and OT must work together. If you skip this step, almost guarantee you'll be redoing things later. Because eventually we see, I'll say this, we see OT organizations or the manufacturing organizations attempt to kind of bypass IT a little bit and to go and start implementing things. Well, eventually IT for a larger organization, they're going to get involved and they're going to have the way that they want to do it. IT, when they're coming into the scene, they need to have the expertise in cybersecurity because it's a lot about security, data management, and network architecture. And OT, of course, is going to come with their operational knowledge. The synergy really isn't optional, as I sort of mentioned before. And I'd also say if you lack experience in this, and that's okay, but this is probably a good time to reach out outside for some help. That investment is well worth it. This isn't really AI's expertise. HMS probably can help, and certainly probably has some partners that can help you in this area. Okay, so again, on step three, we're really jumping into choosing the right IoT technology. This step is really about identifying and selecting the tools and systems that are going to propel us into the future of smart manufacturing. This step is where that strategic vision starts taking on a real tangible form, guided by a really deep understanding of what are those business objectives. It's very easy when you start getting into technology to start being wowed by this or that shiny object. I mean, we want to do that. We want to wow you, but you need to pick the products that are really aligned with what you're trying to do. So as I said, kind of go back to your business objectives when you're looking at this. So we wrote out 4 keys. The first key is around scalability. As your operation grows and evolves, your IoT solutions must be able to scale with that. The technologies that you choose today need to meet both current needs, of course, but also accommodate some of the future things. Other examples around this is if you're in China, you need to make sure that your product that you're going to pick can actually go to China. Ask HMS, they can. Ask AI, we can. But you've got to ask those basic questions. Even though you might be doing a pilot in Kansas City, if you've got plants in all over the world, you got to make sure that they're going to be able to support that. Next is interoperability. And this is a complex one um, because this really goes back to your business objectives. What are you trying to achieve? But in the end, you really, done right, you're trying to create a system where you have a cohesive ecosystem. The data flows freely between all of these systems. Maybe not in the beginning. I wouldn't advise in a pilot project that you're trying to connect it with your SAP system, but eventually that's going to be your goal. So maybe in your pilot, you need to see some basic building blocks of that. So keep that in mind. That's a step that we see that a lot of people kind of miss when they're picking different technologies. I don't know that I need to say a whole lot about security other than it's a huge aspect. So you need to make sure that any vendor really can answer and check all of those boxes. HMS does a fantastic job, which is why we love working with them. They've spent a lot of time and money in that area. The fourth element is implementation time. So it's easy to implement. Well, maybe it's not easy. There are some solutions that are they're really impressive, but they take a really long time to implement. So if you have a 5-year plan to roll it out to 25 plants, but each plant's going to take 2 years, that's probably not going to work. So that's where you should get some flavor in your pilot projects is how long is this going to take? All right. So let me turn it over now to Jason Block from HMS and give a little bit more background on HMS's incredible technology stack.
Excellent. All right, thank you, Kurt. I appreciate that. If you'd go ahead and move to the next slide, please. So as we kind of talk through this, I mean, in really trying to be very good at achieving IIoT objectives, the key thing is this connectivity down into the devices that we see down on the factory floor when we look at this. And when we look at the networks that are down on factory floors and we look at all the different types of equipment, there's a tremendous amount of communications technology down there. The networks that are basically running on machines are different from the types of networks that are running in IT-based systems. Essentially, with machine networks, these are geared around doing machine control. So there's a very different set of tasks that need to be achieved down there. Whereas in information systems, we're really trying to use protocols and standards that make it easy for human beings to understand. So when we're thinking about IT systems, you're talking about moving things in JSON, and things that are human readable by nature. Where when you're dealing with machinery, you're dealing with protocols like Ethernet IP, you're dealing with protocols like Modbus TCP, Profinet, all these different protocols are run down on equipment that are designed to run on that machine control. So in kind of ensuring that that you succeed at IoT, one of the key things that's critical is being able to bridge that connectivity gap between the human system and the machine system. So, and that's kind of where we've come into play in this, and we've developed basically a series of what we call edge gateways that are designed around being able to basically bridge the gap from that machine system and moving into the IT system. And the core product in this is a product that we call our Ewon Flexy. And it is essentially an edge gateway that will talk the same protocol in the machine. So it will talk to the PLCs down there. So we understand pretty much just about every PLC protocol that's out there. And then basically capture that data, store that data, and then present it so that it can be connected into an application like Automation's Intellect that can actually deliver that final value that's there, where we basically now we have that visibility, that understanding, that measurement of what is happening down on the factory floor. And we've been doing this for a long time, and we've become very successful at this. So we've actually just passed over 500,000 devices installed this year. They're there to be able to achieve these type of objectives for IoT. And Kurt mentioned security. So our products are based off of a platform that is ISO 27001 certified. So we have basically security is intrinsic to our DNA. It's what we do. So in addition to being able to provide that connectivity, which is the important piece, you have to do it in a secure manner. So we have practices in place that ensure that we are doing everything we can to securitize that data that is saved down in those PLCs and moving it securely in a manner to the humans that need to see that. If you go ahead and go to the next slide, please. So one of the things I want to talk about is the architecture that's going on inside the Flexy. So we talked about the fact that we're bridging the gap between the machine system and the human with our product. So the key thing is to basically have a platform and an architecture that basically covers those core tasks that are in there. So the core piece of the Ewon gateway is what we call I/O servers. And these I/O servers are simply PLC drivers that talk to the different PLC types. So whether you're doing Allen Bradley, whether you're doing Siemens, whether you're doing Schneider, Omron, Mitsubishi, doesn't matter who you interact with there. The I/O servers exist that can basically speak the language that's understood on that piece of equipment. And then the key thing is to be able to move it into the different applications that the humans are using. So we're storing the data inside there and formatting in, for example, a JSON structure so they can be easily imported into information systems. We're also supporting protocols like OPC UA that can be moved into different information systems as and so providing that localized storage and then be able to provide those protocols that are on board. Those are kind of the key things that are part of there. So, and the ability to also within the gateway system is to be able to do some contextualization of the data as well. So we can format in JSON, but we can also add different metadata around that piece of information that we're pulling out there. So rather than basically pulling a number out of a PLC, we can build the metadata around that. So now that when it's basically imported into a system, we have the descriptors around it that are important for that. Go ahead and move to the next slide, please. So the key thing is to understand is that how do we get into the ecosystem of automation intellect? And in addition to the edge gateway and what it's supporting on there, we have a variety of different ways of basically moving data through our systems and moving it into different ecosystems. So one of those is a direct way of interacting with systems, which is to use standardized protocols with E1 gateway like MQTT or HTTPS and building basically specific connectors based off of those interfaces that we can then tie into, core platforms that would tie into automation intellects. But we also have a number of ways that move through essentially our cloud and different APIs that can connect into our cloud where we provide temporary storage. We move the data through a VPN and we can connect into those ways as well. So we have different things like we call data mailbox, which is basically warm temporary storage before moving it into a different ecosystem. Or we also have our M2Web APIs, which directly connect down into the Flexy and pull specific values and essentially in real-time data. So we have different mechanisms for pulling historical data, and we have different mechanisms for pulling real-time data. And we support APIs that are HTTPS based that allow you to get that data very easily and move those into those ecosystems. So that's kind of the key thing is making our system easy for our partners to use so that they can ultimately deliver the end value that we have there. So that's really when it comes down to it. This is the contribution that HMS is bringing to automation intellect and the value that they bring. So we're a piece of the system while automation intellect is really delivering the final result, the end value, the measurables that Kurt talked about earlier that are important. And with that, I'll go ahead and give it back to you, Kurt, and let you continue.
All right. All right. Thanks, Jason. Okay, so we'll keep going on the topic of choosing the right IoT technology. And for us, that is definitely the foundational element for us is really the HMS technology. So quick story, when I started back in 2017 with AI as one of the founders, and we had this idea of creating this. I have a lot of IT experience, but I didn't have the experience of how do you get the data out of these PLCs. So I went to an HMS event and immersed myself into this technology with HMS, and we didn't want to like just assume that this was the only thing, so we actually evaluated a couple other products, and we just kept coming back to HMS. It's just fantastic technology. So why? For us, flat out, it works. It's very consistent and reliable. But the three reasons I would throw on there was really around security, which we talked about. They have consistently upped their game on the security aspect. So, and if you're implementing something like this in your plant, that's depending on your role, this is one of those things that's going to keep you up at night, because you had a plant that had almost zero connection to the outside world, and now all of a sudden you're enabling that. The second is flexibility. The diagram that Jason had up there talks about the way that we use it, and this picture here does the same. It's just an incredible piece of hardware and software. We can reliably go into lots of different customers and connect to their old machines and their new machines, all using the same piece of hardware. The third aspect, and this I don't feel like HMS broadcasts this as much, but that is you're getting a piece of hardware, but you're also getting a piece of software. There's a lot of it's basically a programming platform for getting data out, manipulating it, and for us, we use it to make some small changes and send it up. We also use it a lot for shop floor screens. It's a huge asset to our product and our platform. All right. Okay, so if you're attending this webinar, I assume you're okay with a little bit of advertisement on AI, but I need to set this up so that you can really get to how we're actually doing this 50x ROI. So we talked about selecting the right technology. It's based on your business needs, but in keeping in mind the ability to scale, be secure, and to be able to operate with your other tools. So on this slide, on the top left, you can see that PLC sensor and input. That's the heart of what we do in using HMS technology to pull that into our system. On the left-hand side, there's also that interoperability discussion. So we've got our enterprise systems, our ERP, our MES, our CMMS systems. Our product basically can read and send data. So it's a bilateral type of movement. And then we have a lot of clients that their technology or their equipment, the only way we can get the data in is via manual input. That's not our desire. We want to get as much into the system in a dynamic, real-time fashion, but the reality is that some pieces of equipment, that's just not going to happen. So, all right, on the right-hand side, we have a number of audiences we're trying to help. So I'll start with a plant manager. Plant managers can use that plant view, tier 1 view. They've got machine detail and a lot of alerting. On the moving down a level, we have advanced analytics, which we can, our best implementations, frankly, have somebody from the client who might actually be from IT, but can help out operations with developing fantastic reports. So our system comes with reports, but our system comes with a built-in BI tool that you can basically build reports on all of that process data that we receive. CI managers can use daily reports that come out, alerts, and use the core product, which I'm going to show you an example here in just a second. And operators can use the real-time screens. So these are shop floor screens that are powered a little bit by HMS, and we send data in. So it's a bilateral, but in the end, our operators on the floor can see how they're doing in real time. All right. The best part is that once we have these PLCs connected to the Ewon and the Ewon connected to AI, it literally takes hours to get the data flowing and up into our system. And that's where, frankly, you're going to get all your value. Okay, so in the next slide, I'm going to show you, I'm going to go through 2 case studies of how we've achieved that 50x ROI. Okay, so this is an example of one of our screens. We affectionately call it the machine detail screen. Yes, I know it's not very catchy, but it gets the point across that this is basically the heart of any machine that is built in, that is being data is being sent into our system. It has a number of tabs that are focused on different aspects of machine performance. So everything around OEE and really all of its components are on here. I'd say the tabs that are probably most often used by our customers are around production, faults, and downtime tabs. So let me jump into, everybody loves a story, so let me jump into a quick story. And then after that, I'm going to talk about a real life case study, but they're very closely aligned. So meet John, the CI manager at Acme Manufacturing. He receives a call from his plant manager asking some tough questions about line X. Production's been slowly decreasing and they're not meeting demands. The plant manager is considering buying some more equipment. I mean, it's not going fast enough, so we need to make an investment. John jumps onto his laptop and begins exploring using AI. And he can start at various different places, but with a few clicks, he's now focused on line X. And he can see both historic and real-time trends for that particular line and data. And several insights, they're actually being pushed from the back and telling him that they're experiencing a lot of changeover. And he's also being informed that there's a specific fault that seems to be occurring quite a bit. So from John's experience using the platform, he's able to jump onto the faults tab and click to see the fault screen. And he looks at a trend on fault 55 and he can see that it's been increasing. It was 5 minutes per day, but now after a few months, it's actually 2 hours of downtime per day. It's been happening a lot, but it's just not enough for everyone to see the issue. It's what we would call a microstop. And they're at this point growing beyond microstops. So he opens up a maintenance ticket within AI, which is connected to this CMS system. And he also uses the action function and he writes a quick note about what's going on. And he's able to send that on to the plant manager to let them know that he is doing something. Okay, so let's jump into one of our case studies where we're talking about 50x ROI. The story I just told you has actually happened at several times at our clients. It's one of the first things that we look at when we do the initial installation because these microstops are things that are hard to see, and our system basically allows for that visibility for the first time. So imagine a scenario where the production lines are routinely paused. It's a common but overlooked issue that significantly impacts productivity. With AI, you're able to see that. And so when we translate that 233 hours of unnecessary downtime every month, that's about 14,000 minutes of pause time per line each month. This isn't really just lost time, it's literally potential revenue slipping away. So if we talk numbers, we can assume a conservative value of just $1 per minute of production time. So that equates to a staggering 710,000 reclaimed each month. We're looking at about $8.5 million recovered in recovered capacity. That's a huge number. A lot of times when we come into sites and we start talking about those things, it's kind of unbelievable. But when you really get down to it and you start putting some numbers to it, it's reality. Now, there's some key points to this. Two things. One, you have to do something. We have a number of implementations where they don't have a good team, and so even though we're pointing out these things, they're not actually doing anything with it. And so obviously, if you don't do anything, just having the data doesn't help. We do, as part of AI, we have a value team that works with you to try to highlight those things that we're seeing. And I think that that's one of our huge differentiators. But again, this gets back to having the right team. You really have to have the right team to take the information that we're giving you and to dig into it yourself and to make those changes. But all right, so let me go on to this next slide. So let's go back into kind of story mode for just a second. On the left-hand side, well, actually, let me set up the story. So let's pretend we're back in the plant. The shift is ending. You're putting on your shift manager hat. It's time for the tier one process. So meet Jane, the new shift manager, and her new tool called AI Tier One screen, which is what's showing on here. On the left side of the screen, you can look at the entire plant. This is a configurable part of our solution, and you can look at that, and you can see if as you click on a specific machine, you can see the data on the right-hand side, and you can see how it's doing at that tier or at that shift. So Jane's already done a quick review of the previous shift's production and some of the notes that were taken during that last shift. With the group gathered around, so picture in your head, the whole team can see all the lines and the machines in the plant, but she's focusing on one particular line. The whole point of this screen is basically to allow for that tier one process. The group that can see that there was significant downtime on one of the lines. Frankly, an alert had already notified her that this line had taken a long break before and after the midnight break. She asked the crew what happened, and they kind of sheepishly told her that it was Mike's birthday and they had a small celebration. Okay, nice. There's nothing really you can do with that. But there was some other issues, and there was some maintenance issues that probably are required. So she's able to use the tool to see the issue, talk about it, and then they can take some actions from it. So she completes using the action button. She basically starts to figure out what needs to be done, document it, and send that off to the maintenance team to actually take some action on it. So this is just an example of how you can use the tier one dashboard in our case to really take some action. So let's look at a case study using some of this stuff from AI that really helped to understand and make some huge, huge improvements. So AI has an analytic that churns in the background. It looks for all breaks and lunches and writes that time from the last good part to the first good part around breaks and shift changes. By creating that detailed report from the production timing, we've been able to quantify the overall cost of these delays. This isn't about finger pointing. It's not about tracking for the sake of tracking. It's really about understanding where is the time lost and how can we recapture it. Our platform has utilized actual machine production data, eliminating the guesswork, enabling us to rely on accurate, real-time, and repeatable data. And in this case, the results speak for themselves. It identified an average of 72 minutes of lost production every single day. If you're thinking in terms of parts, in this case, that's about 27,000 parts per day that were not being produced simply because of those elongated break times. The implications are enormous. As you can see on here, eventually we're talking about $8.3 million in recovered capacity. Again, I'll emphasize the key is having the data and then taking some action to improve that. Obviously, in this case, there probably were some discussions with union and other things. It's not making these changes. I don't want to oversimplify it and say you just find it and you just make a quick, easy change. We all know that's not the case, but the first step is certainly knowing it, and the second step is actually doing something. Okay, so we've shown some case studies of how you can get that 50x. So you've developed your strategic roadmap, you looked at your infrastructure, you selected some tools, and now you're ready to do some pilot implementation. So I wanted to end the presentation with the pilot implementation and then some comments about final rollouts. So when you are going to do a pilot, well, let me step back. Pilots are, from our perspective, they're kind of a necessary evil. They slow down the actual implementation and you getting value. But from an outsider and a recommendation to you, I mean, pilots are probably just the way it has to be. Um, you, there's been a lot of failed projects, so it would be ill-advised for your career to start with a rollout to the whole plant. So you're going to do a pilot. Once you start the pilot testing and training and our IoT journey, we hit the reality of change head on. Change, particular in the dynamic landscape of industrial technology, it can be hard. A lot of operators, frankly, they're experts in their craft through years of experience, and are likely going to shift. They're likely going to view this change with a lot of skepticism, and it's not necessarily unfounded. It's a reflection of both their experience and, frankly, a lot of failed IT initiatives over the years. Um, at AI, we do understand this, and we understand that trust isn't given lightly. Our structured approach towards implementing each line is designed, frankly, with that skepticism in mind. And you should have that as well when you're trying to implement these things. There has to be the kind of these four keys: that crawl, walk, run. You have to have a structured approach to it. You really need to be respectful in a world where that's not always the case. And you have to do thorough testing. And thorough testing from us is, before we even give it to the operators, we have to have tested it and have validated it before we put this out on the shop floor, because it's easy to lose the faith of people, especially when they're looking for it not to necessarily work and they've got a lot of skepticism. All right. So now we get to the full-scale implementation. This is the final curve of today's discussion. It's essential to highlight not just the what and how, but also when of a full-scale IoT deployment. True scalability means expanding our IoT solutions efficiently, not just across locations, but also within tight timeframes. There are four keys that I'd like to highlight. The first is going back to that strategic plan. This goes back to one of those first slides that I showed. A successful full-scale IoT implementation hinges on meticulous strategic planning, standardization, and seamless integration of interoperability between all of those other systems that you have. The next piece is standardization. If you're going to scale, you must standardize. We feel like AI shines brightly with this ability to standardize. One of our kind of internal slogans is configurable but not customizable. And I say that because if you're going to roll this out to 25 plants and you implement it for line one, and then you're going to implement it for the next 5 lines in that first plant, you can't keep changing the way that you're capturing the information every time. It just isn't going to work, and it's going to take too long. Our goal is to implement on one pilot line, then your plant, and then all of the plants, and to do it quickly. That's part of what you'll get from that pilot, is to figure out how long is it actually taking to do this. The next piece is integration. We talked about the interoperability. At this point, when you're doing full scale, you need to be really pulling back that plan of what needs to be integrated. What are the goals? How's this going to happen? What are the systems? What's the timeline? This is not an easy thing, and it needs to have its own testing and change management. Training and change management, I'll just put those two together for the sake of time. I just cannot overestimate how much change management comes into play. If you don't do this well, you're going to end up having, it's going to feel like you're fighting with your own team to try to implement this stuff. So do the training, which helps people to change, and dedicate some time and money and everything else into that. All right. Well, thank you guys for participating in this webinar. I'm going to end it here. and we can take questions if we have any.
All right. Thank you, Jason and Kurt. Additionally, if you have any questions that you're not able to ask right now during the Q&A, you can reach out using the info provided, and we will be happy to assist you. If you have any questions at this time, please use the raise your hand feature, and we will kindly unmute you to ask your question. But to kick things off, I do have a question. What are the main obstacles you have when implementing for your client?
So, Jason, you want to take that? And I probably have some comments too.
Yeah, I would say, there's different obstacles based off of different perspectives. I would say from ours, probably the biggest challenge that we run into with customers is getting everything connected. The phrase I like to say is that the decisions we make are only as good as the least available piece of information. So when you think about it from connectivity down on the factory floor, that piece of equipment that we don't have connectivity, that island of automation that we can't get access to, that can be potentially one of the obstacles there. So that's what, from our perspective, that's where we kind of see one of the key challenges is that first step is that making sure that everything that you need to see that basically feeds into your plant operations is available there. So I'd probably see that as probably one of the key obstacles there. And then the biggest challenge then is we kind of talked about earlier is then making it available in something that people understand. Machines and people talk different languages, so you have to basically present in a way that you're understanding what one is saying, but being able to present it to something that another can understand. So I would say that's probably one of the key obstacles we see.
From our perspective, it really comes down to a lot of that change management piece. We're putting in a tremendous amount of new technology, taking a lot of people who have had, basically everything done on spreadsheets and whiteboards and moving to an enormous amount of information. And sometimes there's skepticism. So we have to really, on the pilots, we have to really do a lot of validation and getting buy-in from everybody. And we have to, at times, the other piece I would say is, um, we have, frankly, some people who don't necessarily want to make that change, even at some of the upper management level. So it's a lot about change management. And whether it's our product or a lot of other IoT products, change is hard.
Awesome. And then another question, what happens to the data if the plant loses network connection to the internet?
Jason, you want to take that? I
Yeah,
live
I'll
it.
take the first run at that. I mean, the good thing with our platform is that we have there's two things. I mean, we're pushing information up to Automation Intellect, but the good thing is that we're storing the data locally. So if there is a connection, let's say if the plant is taken offline and the connection to the visualization platform is lost, that data itself is not lost. It's stored for a significant period of time. There's a significant amount of data storage within the Flexy itself. So it's non-volatile memory, so you actually have that data there, and and the historical data is maintained as well. So it's not just the current values that are held into there. There's the history in there as well. So once that data is available, then you can actually pull the whole history. So you never really lose your snapshot of what happened in time. It's just a matter of when you get a connectivity back, you now have that information available to you.
Yeah, I'll add on and say probably a lot similar. Well, this is one of the things that we love about the HMS technology. It has multiple tiers that protect us from that. That is the reality. When you're at home, you lose your internet, right? It just happens. It's going to happen at your plant as well. So as Jason said, that data will stay on the on the Ewon, and then the next layer is this data mailbox concept. If we, for some reason, we have any problem on our side and we're not able to gather information from the cloud, well, it sits there too. So we love this technology because it has kind of multiple failover solutions to ensure and protect against what is inevitable.
Awesome. And then how long does a typical pilot last?
Mhm. It depends. Our goal is about a month to do that, but it definitely depends on what's being asked. If there's any ask of connecting it into external systems, the complexity of the machines that we're trying to pull from. So anywhere from a month to 2 months is that pilot. And during that pilot, we also obviously we learn a lot about the rest. So usually the pilot is by far the longest piece, and then once we get the go ahead to go to the plant, it's a lot more cookie cutter because we know more about the team and we know more about what's being asked, and usually we know more about the equipment as well. So
Awesome.
And I'll offer maybe a little bit additional perspective on this in terms of pilot, times of pilot. I think a lot of it comes down to is coming back to some of the things that Kurt talked about the concept of basically smart. And I think it comes down to the organization itself when running a pilot having a clear idea of what the outcome is, what it is that they're trying to measure, what they're trying to understand. If you have a very good snapshot of that, sometimes the pilots can run a reasonably short amount of time. If the organization doesn't have a good idea of what they're doing with the system, then pilots can run as they kind of try to seek where the value is in that. I mean, would you agree with that statement there, Kurt?
100%. Yeah, that's where you can sort of tell in the beginning um, what people, if they have specific objectives, or if it's like it's not really like kicking the tires, but it's more of we need to do something. We don't know exactly what we're going to do once we have it, and so by almost definition, it's hard to say we're done.
Awesome. Well, I'm not seeing any additional questions or hand raises, so I think that wraps it up for the webinar here. Thank you, Jason and Kurt, for this presentation today.
Yeah.
And we'd like to thank you all again for attending and have a great rest of your day.
All
Thank
right.
you.
Thank
Thank
you,
you, guys.
everyone. Bye now.